Well, hello and welcome to the Skill Me Up expert talk on Azure Logic Apps entitled Orchestrate and Build Serverless Solutions with Azure Logic Apps. My name is Brian Gorman, and I'll be taking you through this journey today. There's a little bit of information about me. I've been programming for about 20 years, so I've been around for a while. Probably most of you have relative similar experiences. So there's just a little bit about me. I've been training for a while. I do have an MCT, an AZ 900 certification, and a couple other things as well. Yeah. All right, so the main point of today is I want to introduce you to Logic Apps. So please feel free throughout this talk to ask questions in the chat. I'll have that up and monitored on my other screen so I can see your questions as they come in. Also, I would really love to hear from you. What level of experience you have right now with Logic Apps? Would you rate yourself an expert, intermediate, or just have never even heard of them, or beginner? If you could just let me know in chat, that'd be great to kind of help me get a gauge on where everybody's at. Okay, so I see some intermediate coming in. That's great. And basically what I like to do throughout this talk then is get a chance to just introduce you to Logic Apps. We're going to talk about why you might use them and how they can benefit you. And we'll go through a bunch of the different things you can do. We'll basically dive into a few things that'll show what you can do with Logic Apps, but we can't possibly touch everything Logic Apps can do in just a 45-minute talk here. And so with that, please keep in mind that this is going to be a launch point for you and an introduction enough to get you going and see how certain things work. But if you have questions, I'd love to hear them along the way as well. So yeah, so it looks like we got a couple people just starting out with Logic Apps, just trying to learn about them. That's awesome. And a couple people just want to maybe get a little better at them. So that's even better. So we'll look at the different views you can do, the designer versus the code view. We're going to talk about the main moving parts, and then we'll actually dive in with some samples here that show how this works and how it all moves together with a practical application that I built to monitor tweets and send emails and do a few things to Cosmos DB. So you'll see all that easily working with the Logic Apps. We'll wrap it up with talking about how you handle errors, looking at getting monitoring, getting alerts, and of course, everybody wants to know, what's this going to cost me on Azure? So we'll wrap it up with a little bit about pricing. Along the way, we'll also talk about some good strategies and bad strategies that I've encountered as I've been doing this stuff. So what are Azure Logic Apps? So the first thing to keep in mind is that Azure Logic Apps is actually the name of a cloud service, but we still say this is an Azure Logic App, even though it's the actual cloud service. We'll build an Azure Logic App. So the main point of the Logic App is to be a serverless orchestration. And what I mean by that is we're going to be able to start building out our processes from start to finish and connect them with the different procedural methods that we'll put together to basically orchestrate an entire workflow. So this is really handy when you're talking about needing to do a few things like background jobs. Instead of having to spin up a server and put a Windows service on there, you can actually just have an Azure Logic App that is scheduled to run at a specific interval. You can have it check every minute, every hour, every day, every few days. So they're pretty awesome that way. And the integrations that come along with the Azure Logic Apps helps you to do things with your processes in a much more efficient and quick manner than it would take in your traditional programming environment. The main point I want to make is that when we're building out our Azure Logic Apps, we want to keep them simple. You want to make succinct units of work. You want to keep them small. But if you start building these large monolithic serverless applications, you're going to get down into a whole bunch of rabbit holes that are going to cause you a lot of problems. So when you're going to start building an Azure Logic App, the first thing you should do is plan, and you should plan well, because you need to make sure that you know where you're going so that you don't end up going down those rabbit holes. Once you get them and once you start using them, what you'll see is that they're really easy to maintain and manage, and you can usually get changes much more quickly than you would in your traditional development process as well. In fact, you could deploy overnight very easily with the click of a button a change to your Logic App, or even during the day, and not have to affect any other part of your solution. So why use them? Well, they come with a lot of benefits, but basically you're going to start being able to take your processes out of your monolithic applications. You're going to be able to start building out these workflows, and you can integrate them back with your applications very quickly and easily. There are a lot of different connectors. We'll talk about those today, which will show us how we can integrate our Logic app and how we can actually go out and get our Logic app so that we can run that from our code, and how we can get back to it once we're done with the Logic app, get back to our code. So one of the really great things about putting these on Azure is that we'll get the ability to have massive processing capabilities. So this can be good and bad, of course, because what happens is you're able to quickly spin up a Logic app and process it very efficiently. But you can also spin up too many Logic apps and process them very efficiently. And we'll talk about that a little bit as we get into some things here later today too. The nice thing about Logic apps is that being inside of Azure, it gives us a chance to also integrate all of the other parts of Azure. So rather than having to connect our code to the Key Vault and getting a secret and then go back to our code and then do something else and then go back to Azure, you can actually orchestrate all of that right in your Logic app. You can go get your secret from your Key Vault. You can send it to a function. You can process that through other parts of Azure as well, logging things in Cosmos DB or whatever you need to do for storage, blob storage. You can monitor. It's really quite powerful. And so we're going to look at today sending an email from an event. So the main point is with using Logic apps, they're really good to respond to events, and they're really good to be triggered by something else. So if you have your monolithic application that needs to do something and you separate the process out, if the event that happens that needs to trigger that process, you can simply call the Logic app and make it happen. Or if you're just monitoring something, that trigger will get it going. So again, they're easy to monitor. This is going to be, you'll see today how easy it is to set up alerts and monitoring within Azure on your Logic app, so you can see when things don't work and get notified and figure out how to respond to it. And another nice handy thing about it is when you're building the Logic app in the portal, you actually have a version control that's built in for you. You don't have to do anything. So if I start building today and I get down a rabbit hole and I decide I want to go back to where I was, I just can easily look back at my history and see where my version was that I wanted and restore that and promote it back. And then my Logic app goes back to the way it was. The other thing that you can do to make sure that you keep them from getting lost is you can basically take the JSON that's the code behind for the actual Logic app, put it in any JSON file in any Git repo. And so you'll always have your history that way as well. You can also export ARM templates. So when you do that, you basically can then use that for redeployment. You can use that for getting your Logic app set up across subscriptions in different environments and such. So what I'd like to do next is actually start looking at what it looks like to work with an Azure Logic app. So here you'll see, I'm going to go ahead and go out to the portal, and I'm going to start searching for Logic apps. And there's multiple ways you could get it. It's usually in your history, or you can search for it. But when you go in, the first thing you're going to want to do is select your subscription. And then, of course, you can see any of your subscriptions, but you can also get a resource group. And so here you're going to see me picking the Logic Apps resource group, but you could create a new one if you didn't have one, of course. You need to name your Logic app. And so this is probably the most important part of the entire process, believe it or not. The reason I say that is because when you name it, essentially, once you name it, you can't rename it. So we'll see that naming is actually a really big deal within the Logic app process. So as we continue to build this out, we want to make sure to choose a really important name that's already well planned, because again, once we make it, it's there forever. So it does have to be unique in the resource group. So you see there I had a conflict, so I just made a new one. And then there's two different versions, region-based or integration service. I'll talk about that in a second. Here I'm picking a region, and the log analytics here you could turn on if you wanted to. We'll do that later, so I'm going to leave it off. But you see here I do have a log analytics workspace you could have just enabled here. So with that integration services, here we could add tags, and then we could also review here, create, make sure everything is good to go. But if we look at that integration services choice at the very beginning, it gives us the chance to know that if you wanted to, there's two different ways to deploy this. Again, regional or in with that integration service environment. The integration service environment is what you're going to want to use if you want to use private VPNs or you want to keep your stuff off the public cloud. So even though you're creating a Logic Apps in your subscription and in your resource group, it will have a public endpoint if you do just regional. If you do that integration service there, you see that you actually can do it privately within your own VPN. So there's two different ways to go about building out your Logic app between a drag and drop designer and a code view. Now there's also a tool with visualstudio.net that we can integrate with Logic Apps, but we're not going to talk about that today, but I just want to make you aware of it. So here what you're saying is I'm in the designer mode, and when you start out, there's different connectors for the common triggers and then templates there. And this is on the left-hand side, you see the designer and the code view. And so when you're in the code, you see it's just JSON. You can't see it very well here yet because I didn't get it expanded over, but there's not much there anyway out of the box. But what you're going to do when you log in is you're going to see this designer view, and then you're going to want to be able to start selecting how you're going to start that out. So that's where triggers and connectors come into play. So when I want to start building my Logic app, I'm going to use a trigger. This is going to be what makes the thing start. It's either going to be a scheduler, it's going to be some connector that responds to an event, such as an HTTP post or social media. And one other thing that we won't see today, but is important to note, is if you do have a trigger that's an HTTP post, they're extremely easy to test using Postman. So you can just get the URL and send your payload and actually trigger from your desktop the Logic app, just like you would if it was from another third party. So here are some common triggers that you'll probably run into as you start working. So you see there's social media integrations for Twitter, Facebook, etc., but there's also Office 365. So if you want to respond to things like you received an email, or a new file was dropped into a folder on OneDrive, or somebody posted to your API that you basically exposed here, so the HTTP request, or even a service bus or an event grid that's happened within Azure. You can respond to all of that. And so there's a lot of different possibilities to kick off your Logic apps. Okay, so I'm seeing you're not able to see my complete screen of demo on the actual Azure portal. Okay, so this is in a widescreen format, and it is on the right-hand side of these are actually within the slides. So can you see the stuff on the right hand there with the HTTP request received and such? That's where they're at. So yeah, I'm unfortunately not able to resize that at this point. Okay, so the other thing about it is after you choose, if you don't want to use a trigger specifically or a blank Logic app, you can actually use one of their templates. And so they have a number of templates in place for common processes, and you can click on these and it will actually just stub out the entire Logic app that you need to do that process. And once you can do that, then you can tweak it a little bit to meet your needs. So you can also search for them by category and by popularity to see if those are going to be able to meet your needs. So here what we're going to do is just select a trigger. We're ultimately going to select that tweet posted, but what I want to do is just show you on, you can create a blank Logic app, or you can go over here and you can find a sorting or category. So here we're going to select social media and see if there's different social media templates we wanted to use. So you can see there's quite a few. And basically we're just going to say, you know what, I'm going to build my own, I'm going to roll my own. So I'm just going to, when a Twitter has got a tweet posted, and you see it was connected to my actual Twitter account, BL Gorman. I set that up ahead of time. If you do this for the first time, you have to create that connection. You just authorize to Twitter. Now, if you've ever worked with a third-party social media integration in any of your code, you might know the pain that's caused by all the different things that happen, such as getting that thing to actually work with the setting up the app and all that stuff that you have to do at Twitter or Facebook. And with a Logic app, it's basically click a button, authorize yourself, and you're good to go. And you don't have to worry about when Twitter updates their API because Azure is going to take care of that for you. So all triggers need something that you can do to set them up. So this one here, we're going to do an actual hashtag search. So if someone puts in some important hash, now I did leave the H off on purpose there. We'll see a fix for that in a second. But you can see, how often you want to check. So here we're going to set it to 1 hour, and then there's a couple different parameters, time zone and start time. I'm going to select them first, but later I'm going to decide I really probably don't need the start time. So I'm going to go ahead and set my time zone to central, and then I'm going to go ahead and delete that parameter that I don't want anymore for the time. I don't care about that. And then what you'll also see is that connected to my Twitter account, but you can actually change the connection there. It's not extremely easy to change the connection. Sometimes it gets a little confused, but you can do it and change to a different Twitter account if you want it. So if you were doing an HTTP post, you would probably have to give the expected JSON body. You would need to do any other authorization that you would need to do if your trigger requires it. So there's two ways to edit your stuff. Like I said, one is the Logic App Designer. And if I save that there, that would actually have fixed it. But what I want to show you is that I can actually go into the code view and make changes at any point. So here I'm going to select code view on the left, and then I'm going to find where I have my misspelled search query there, and I'm going to actually add the H there, and then save this. And that gives me the chance to update the Logic app through code. And I go back to the designer and it's fixed. So you can see that they work in tandem. Note up at the top, there's also a designer and code view that you can click on there as well if you want to just flip between them right at the top of your Logic app. Once you're done making your changes, of course, you want to save it. So we have our trigger in place. Now it's time to talk about the body of our Logic app, and that's going to be done through the connectors. And so what we'll see is that there are over 200 connectors already in place at Azure. So they have everything that you could pretty much think of. They have something. Of course, you may run into some certain situations where you need something unique. You can always create your own custom connectors, and every connector will be on their own action so that you can actually run it in the process. But things like Azure services, things like your Key Vault, things like your Cosmos DB, things like actually working against an Azure database, all of that stuff is in place in connectors already, and you just have to find the right connector, configure it, and it's actually a lot of pointing and clicking to do a lot of things that, as a programmer, take more time generally to set up in code. So it's pretty handy. So what we're doing here is we're going to go ahead and set up a Key Vault that we're connecting to. And so I'm just going to search for Key Vault. You can see it's right there in the recents because I've been using it. But if it wasn't, I could just type in Key Vault and find the Key Vault that I'm looking for. And I'm going to say I'm going to get secret because I want to get a secret value for my SendGrid key. And so here again, you can change your connection if for some reason you're connected to the wrong person on Azure. And then you can go ahead and find the key that you're looking for. So here I'm looking for my SendGrid API key, so I'm going to select that. Now, once I do that, that actually puts everything I need into that actual unit of work there in that Logic app for the get secret. What's important to note, though, is we're going to want to name that better because as we continue to use these, we don't want everything to be named get secret. We want specific named actions. And with Logic apps, you'll see it's very important to name early, because once something is dependent on, it's hard to change the name without making a lot of disconnected. You'd have to disconnect things to change the name. So you'll see why that is in a second. So I just wanted to take a moment to highlight some of the other connectors that you're going to run into along the way. And you can see that there are actually tabs along the top there where you have the all, the built-in, the standard, the enterprise, the custom. And each one of those contains different things. And so in the built-in is where you're going to find things like your functions, your Azure functions, and your Azure Logic apps. In the standards, you're going to find your storage and your databases. And in the custom, that's going to be your stuff. But you can always see them all from the All tab. So once you start working with the Azure Logic app, you may have a situation where the Logic app itself needs permission, or you need to give permission to something that's happened. So there's a couple different ways to do this. So the Logic app itself can be given an identity. And just like any other Azure Active Directory federated ID, you'll get an ID that then can be given roles and authorization to different parts. For example, you may want to say in your Key Vault, only a specific Logic app can connect to this Key Vault. In that case, you would need to make sure to go in to the actual Logic app itself, find the settings identity, and turn that on. And when you do that and save it, it will get that ID. Then you'd go back into your Key Vault and search to apply the access policy, find that identity. Otherwise, in Key Vault, you can also just authorize all of the Azure Logic apps. So that's the second way to do it. And doing that gives me the ability to just say, hey, if it's coming from a Logic app, it can access my Key Vault, but only with things like getting and listing the secrets, not actually modifying it. And so you see here, we're looking at a Key Vault. This is the access policy, and that's the full Azure Logic apps being authorized. You see the 2 selected secret permissions, no keys, no certificates. What that's saying is that Azure Logic app, any Logic app, can access this Key Vault and can get or list keys, but not do anything else. So now that we kind of understand some of the moving pieces of how all of this works together, it's important to see what a process might look like. So here I have a modeled process. This is going to handle my trigger being when a tweet is posted. And then what you're seeing is a parallel branch. So you can actually do parallel processing, so you don't have to wait for an entire procedure. If you can do things side by side, you can plan that out. Now, once again, parallel branching is great, but as soon as I connect them back, so down towards the bottom, you'll see the SendGrid API URI, and that's kind of down here. Now, what that's showing is that those 2 branches are going to converge here. Now, once I do that, it's really, really, really difficult to add a 3rd branch and have them connect at that same point. So if we're going to do a 3rd branch, we need to do that before we reconnect the 2 branches. Otherwise, you have to disconnect everything, maybe even delete, and it's just a lot of tedium around that. So again, planning well and getting practice at how to build this in the way that you're looking to do it will come with more time. So you see here, it does have the procedural flow, and you see that every single action is well named. It's not just get secret or set variable. And that's extremely important because everything within what we're going to start selecting will key on those names. So here we're going to rename our secret to get the SendGrid API. And that will allow us to set that key value, but also have a really good idea of where it's going to. And so what you see here, the next step then is we're going to want to actually set that into a variable, and we're going to use the initialize because we've never used the variable before, and we're going to call it whatever we want. Again, it's just going to be SendGrid API key here. It's going to be type string, but then this is where it becomes important. See, the get SendGrid API key that we named it is named at the top, and that's how we tell which value we're selecting. So every time you do that, you'd often want to save, make sure that everything's in place the way you want it to. So. Okay, so the next thing I'm going to do is add a parallel branch here, and this is going to just start initializing another variable, and what you'll see is this one's going to come off the trigger itself, and this is where, again, Azure Logic Apps provide you a lot of really useful functionality, because I've done nothing but connect Twitter, but look at all the things I can get from any tweet that I've monitored. I can get names of people that did it, I can get the text, I can get their IDs, I can get every piece of information you'd ever want about a tweet. Now, I clicked too many there, so I can clear it out, just make sure I only get the one I needed. And you see now that I can have that Twitter user ID, and then I can go ahead and do the next one, which is just going to be the username. And this time I'll probably just search for it. And so we can go ahead and find the value very easily just by searching. So there we go, grab the username, we're good to go. And then name your variable. So once the whole process is in place, we've got all of those keys that we've needed from our Azure Key Vault. We've got all of the variables from the tweet we're going to use. I'm going to just build the SendGrid API, which is just an actual a URL there. But this is really interesting. I can just drag and drop basically, or write my JSON and put my variables right where I need them. So now I don't have to do anything to compose that JSON. I just set it this way, and it can basically respond every time. And I'm going to post to my URI at SendGrid. So you see that that's just coming from there. And my SendGrid API key, again, is named from up here. So I can easily put those things into my headers. And in the body, I'm just going to use an expression to basically make my string that I just built into JSON. So I just call JSON and then drop my variable in there. And you see that it's just the JSON variables payload. And that payload is the name of this variable that I created up here. So I want to say, as this starts to repeat here, I just want to say that I could have used the SendGrid built-in connector. There's actually one. You do have to enter your API key directly into the connection there. By doing it this way, I can show that it's very easy to post to any third-party API, but also if I ever need to change my SendGrid API, my API key, I don't have to figure out how to change the connections. I can just go change it in my secret vault. So you're often going to run into some failures. And so what I wanted to do is show you that as you're building out your process here, and this is a little bit of a contrived example, but you can actually build a branching strategy to handle errors. And you can put whatever you want in here and then, of course, process just like any other process. And so this is going to be my error handler here. But then before I do anything else, I want to create my parallel branch for my actual success path. Otherwise, it becomes, again, a little bit tricky to work with, not impossible, but it's just nicer to have this set up ahead of time. So this is going to be my happy path, and the other path is going to be what I do on error. So I'll rename this to success. And then what we'll do is we'll take a look at how do we set the error handler. So over here on the error handler itself, we're going to get this configure run after. And you see there's different actions you can select. So here, when store tweet has failed, this path will run. And over here on the success handler for the configure run after, the succeeded is good to go. And so you can see the left-hand side of there is a little bit red, saying that's the error side, and the right-hand side is just normal. So that gives us a chance to do error handling right there within any type of action that fails. You do have to set it up on every action that fails if you want to do things this way. So you'd likely identify the 3 or 4 that are the most critical that you would want to have information reported to you if it fails. So another thing that I contrived here just to show it is you can do looping. And so this is done through the control connector. And the control connector has a whole bunch of your logical operations, if else, switches, you can see conditions, until is what we're going to choose. So this is like a while loop. And so then you just set a variable. So you would have to set up what's your start condition, what's your actual looping conditions that you need to do inside there, and what's your end condition. So here we're going to say our end condition is that the error text does not contain the word error. So again, this is contrived, but you can get the idea here how you might set something up. Now inside of this, you'll see that there's an actual process chain inside of the until loop. And this gives us a chance to be able to run the process over and over again until we actually get somewhere we want. Now, this is handling error text, so maybe we don't want to loop infinitely on this, which is another interesting point, because you don't want to get into infinite loops on your Azure Logic app. So you need to be very careful. Maybe set a fail-safe variable that lets you know the loop needs to exit automatically because something's gone wrong. Because if you get into an infinite loop situation, remember that you're going to be running up some bills. And so when you start working with loops inside of Logic Apps, be a little bit aware of that and start planning well for that as well. So there are going to be some times when maybe you want to say, well, I'd like to keep my work units succinct, but I want to have multiple Logic apps then to do things. Or you have a reusable piece of code, just like you would in a monolithic application, that you want to break out into its own Logic app. So it is possible to call from one Logic app to trigger another, just like you can call any other connector within the Logic app itself. So you'll use an HTTP request on the other Logic app that you want to post to. And you just need to be very careful here. You want to make sure that you get everything set up the way that you need it to be set up, but you want to determine, do I need to wait for this to be done to continue my Logic app, or do I need to just let it go, just kind of fire and forget it? And so that can be configured within the settings using a thing, the asynchronous pattern, which we'll show in a little bit. But you want to make sure you're very aware of how you want to handle this, because if you have a long-running process that you're calling from within another long-running process, you can run into some really big problems with timeouts, and you don't want that to happen. So if you can't afford to wait, if you just want to fire and forget, you can do that very easily. But you see here, what we did is set up a post to an actual public URL, which we can trigger from our own Postman for testing, but also from within the other Logic app. We'll just pass in the payload there that we want to send to that next part of the process. So here we're going to just create a parallel branch, and we're going to call another Azure Logic App. And so you can look for it just by typing in Logic Apps, and you'll pull in your Logic App, and what you'll see is that you'll already have this configured, of course, but when you've built it out, you've told it what you want in the HTTP body, and here you can just fill those variables in. So you don't have to, again, you don't have to compose all the JSON, you don't have to do any of that. You just drop your variables into the expected fields, and then it will post to your other Logic App for you. And again, then you have to choose whether or not you want to wait for it to complete, or if you want to actually just fire and forget. So here under settings, what you see is that asynchronous pattern. So if I want to fire and forget, I need to turn that off. If I want to wait, I just leave it on. There's other things you can work with there, such as timeouts. Retry policies are very important. Like you get an automatic binary type of retry. It has 4 retries by default, and it goes, I think, 1 minute, 2 minutes, 4 minutes, 8 minutes. So you can have a very long running process if it fails 4 times. So maybe you want to just try once and be done. Or maybe you want to do a standard, try once or try 4 times, but do it every minute instead of waiting 8 minutes. So a couple things that we talked about but really haven't shown, and a couple things that are really important to keep in mind with your Logic Apps is going to be that you can use your Postman to test your public ones. Well, once they have a public URL, you can trigger them with the Postman. With the Azure functions, you can actually integrate those in here as well. So we likely know, if you don't, Azure functions are really great for, again, making serverless processes, but they're succinct units of work with specific time limits and different things that you have to manage about the function, and generally for one thing and one thing alone, and they're not orchestrated. So it's processing a file or looking for some sort of input that it then does something else with, and that's that unique serverless architecture for that function. But maybe I want 3 functions to be run in concurrency or in consecutive order, and I can use the Logic App to orchestrate that. So the last thing here is this concurrency control. So if you remember, I talked earlier about the massive processing to scale. And what we can see is that as we spin these up, if you start spamming it really fast, you can actually run Logic Apps extremely quickly. So they're obviously built-in processes run by a computer. So if I say, process my database, and it's got 1,000 rows, and every row in that database is making a post to my Logic App to trigger it, and then that thing's doing something else, like posting to someone else's API or doing anything else, you can actually start getting yourself into some weird, almost denial of service attacks on yourself. And so you have to be really careful. So you need to plan well how you're going to handle that, but you can also just say, you know what, I know that this is going to be crazy. I just want to say that I only want one to run at a time. So if you turn this concurrency control on, you can guarantee that only one of them will run at the same time. So once we get everything in place, we're going to want to obviously determine what's going on and how things are working. Are they working well? How do we respond to it? So you can dive in to any Logic App and see the previous runs. So here on the left, you see I have my Twitter Monitor Logic App, and in that Overview tab, I have 5 runs. 3 of them failed and 2 succeeded. So I can click on any of those, and it would give me the actual Logic App process, and it'll have exclamation points if they failed or check marks if they succeeded on each step. And I can drill in. So where one failed here, I can drill into this and see that I had a bad request when I tried to post to the API at SendGrid. So I can figure out what my inputs were, where did I go wrong? Because you see, when a tweet is posted there, you see that actually when you're reviewing these, all of the variables and all the things that came in with that body are actually right there for you. So you can review what was the text, what was the ID, who did it. All that stuff is given to you in the review. Even though the run is done, that information is available for your review. So you can find what went wrong or what went well or what you didn't quite process the correct way. So here I'm going to set up an automatic alert. So when things do fail, I'm going to go out to Azure, create this alert, and I'm going to say when the run fails, and then I want to say with a count greater than or equal to 1, I'm going to conglomerate that to only evaluate every hour and basically just aggregate it for the hour. That way I don't spam myself with a bunch of emails. And you see that costs me 10 cents a month to run that alert. So that's my email group. So in my Brian's Action group, I just have my email. So now as soon as that alert triggers, it will actually send me an email saying your Azure Logic app has failed. And it might give me information about why or not, but either way, I have it in place. The severity, I think, is just for you to pick how severe is this error in my process, and you can kind of rate those yourself. So this is the diagnostic settings going to log analytics. If you remember back at the beginning, you could actually set this up right away from the start, but I wanted to show you that you can do it once it's created as well. So you do need to have a log analytics space, which is already created for me here. And then you can actually archive it to storage. So if you want to keep a retention policy of say 30 days or 90 days, you can keep that. You click on the two workflow and metrics runtime things there and get that sent to your log analytics. Now what that does is gives you some really nice displays for things that are going on. So this is in my log analytics, then on my Logic Apps. You can see that in the last 24 hours, which I can configure, that 24 hours could be the last hour, the last couple days, the last week, the last month, whatever I want it to be. But in the last 24 hours, this thing ran 4 times. 2 of them succeeded, 2 of them failed, and there's not currently one running. And then you can see more information about that you can drill into. There's also up there at the top, you see there's a refresh so you can get some live data. But there's also a logs tab. Now the logs tab is a little tricky. You got to run some queries against things, but it's something to look into if you're specifically supporting these Logic apps. And so you also see here on the alerts tab itself, I can look in and see what's going on with my Logic app on the Twitter monitor. So it says once I've sent some alerts, things will start showing up here too. So not just the email that I got, but hey, we did this and this failed a couple times. All right, and so now pricing. So everybody cares about what's this going to cost me? I'm running these giant processes now on Azure. So I took this directly from the Microsoft website. You can see here that it's Azure Microsoft Com pricing details Logic Apps. And what you see is that the Logic app itself has a minimal storage cost. So you'll likely see maybe a few pennies on the month to pay for that storage of the Logic app, unless you go crazy, right? But once you actually start running it, that's where the cost comes into play. So that's why it's so important to keep those monitors in place and make sure you're watching stuff happen, because if you get into those infinite loops, or if you get into a situation where this thing is running, but the actions are firing over and over again, and I'm firing thousands and thousands and thousands of actions, that can start adding up cost very quickly. There's connectors on the actions, so you're adding some money there. And then if you build your own or use the enterprise connectors there, it's a little bit more expensive. So, use the built-in connectors, figure out how to minimize the number of actions that you need to accomplish your processes, and you can save yourself a little money there. But again, you can see they're fairly inexpensive unless you do something wrong and spend them up over and over again. So that's really all the material that I had as far as in the slides. But what I wanted to do is just finish up here today by taking a look at the actual Logic apps and seeing how it worked when I worked on my Logic app myself. So what you'll see here, and hopefully you can see my screen. I'll keep it just a little bit to the left this time, since I know some people were having trouble seeing the right-hand side earlier. What you can see here is this is my Twitter monitor, and there's the action that I made earlier. You see that I'm looking for Sci-Fi DevCon here, and when that happens, I can do things with it as well. I can set all of my information that I wanted, and then I have all of my stuff that we saw with my 2 different sides of the processes. I'm composing my API push to SendGrid here. I'm building out my payload, where again, if I decided I wanted to do something different here within what I'm sending to the actual email template at SendGrid, I could just modify this part of the Logic app right here. And so you see down there was that left-hand and right-hand side if things were working or things weren't working. So this was the tweet info storage. And so I wanted to show this because this is actually storing to Cosmos DB. And so I wanted to show you how easy this is. So not only am I emailing myself when I get a tweet, but I can actually just chain that command here. So you see that I'm looking for different information when I chain that in that makes sure that I can store this in Cosmos. And then I'm going to parse out the tweet info from that JSON, which is the exact same body, but that gives me the ability to then go in and build a variable off of it. And you can see if I wanted to change out my value here, this is again why the naming is so important, because this is the parse out info I'm looking at. And there's the tweet ID I'm grabbing, and then the text. And then I added a connector with an action here for the Cosmos DB. And I set that up to go to my database called Twitter Monitor and a collection called Tweets, creating a document. This is just a create or update document. I did not rename that because I was only using the one. And its tweet ID and its original tweet are just going to be parsed and pushed into that table. And my partition key is set up to be the tweet ID itself. And the response at the end just says, hey, this worked successfully, in case somebody needed that response code. But what that did was gave me the ability to actually start logging stuff right into a Cosmos DB right here. Whenever a tweet happens with that sci-fi devcon hashtag, I can get an email sent to me, and I can also get information posted into my Cosmos DB. And so this was just if we wanted to play around if we had time, but we're running a little low here. So what I'm going to say here is that, yeah, that didn't work out the way I wanted. Sorry. In the monitor here, you see that the monitor alert was resolved. And so what happened is my tweet monitor was failing and failing and failing and failing and failing, but it checks and then it says, hey, your actual tweet was resolved. And so now, or your monitor was resolved. So we know that you've got it fixed. So it's just kind of a nice thing to go there. You see, this is the responses when someone posts with that sci-fi devcon hashtag. The Logic app is kicked off immediately or within the hour because it's polling, I think, every hour. And then it sends me an email and says, this is what the tweet was, and this is information about it and who did it and such. And so that's really what I have for today. And I wondered if any of you had any questions. So, okay, is there a quota throttle like with functions? So I'm not exactly sure what the quota throttle with functions would do, but what I can tell you is that the Logic apps generally will run very, very quickly and very, very, like, if you don't set that concurrency, you can spin up quite a few, because we've run into some issues with that, actually spamming servers, which is why it's important to keep track of how you're actually posting to them or what their triggers are, because yes, if the triggers become crazy, it could actually throttle up pretty high. But I don't know off the top of my head if it does say you've hit 1,000 that are running, we have to stop. So I don't have the exact answer for you on that one. Is there a GitHub repo we can build something like this? At this point, there isn't, but I could put one out there, and then I could have the people at Skill Me Up can send you the email with a link to a repo that I could put my Logic app code in. And what you would want to do then with that, let me just pull this back up. So what I would do is just have this simple file, and the file would be available to you. It would be as this code, it'd just be a JSON file. And what you would need to do, though, the problem with this is that this is going to be set to things like my subscription ID, and it's connected directly to my Twitter. So you see I have key vaults and connections here. So I might have to remove those, and also you would have to re-add them back in. But you could then just say, I want to create a new Logic app, or you could, and then just copy paste that code in. So once you did a new Logic app, you would be able to do that. So if I just said Logic apps and I said new, and then of course went through the whole process and named it and deployed it, I would get that blank code. I could just drop the code in there. So I forgot to show you one other thing that I really want to show you. So remember I said there's version control built in. So I can look back at the different versions that I've built here. Now I can't get a lot of information about it, but so you kind of need to know where you were. So if I say, you know what, I know at the end of the day yesterday, this was where I wanted it to be, I can click on that one and it'll show you what they are or what they were, so you can review it. So yeah, that's the one I wanted. And you can click on this promote button. And as soon as you do that, then that will make this your current version. So that's really handy when you want to fix some stuff. What other questions do you guys have? All right. So without any more questions, then I think we'll just go ahead and wrap up. We have a couple things here I just wanted to remind you of is, again, you're going to want to make sure you plan well and keep your names in a way that's very easy to manage. and you want to keep your logic apps simple. Don't build a monolithic logic app. That's probably the worst thing you can do. And you're going to have to reframe your thinking when it comes to that. So if you start using these, think small and keep your processes isolated. You can, again, use any kind of trigger you want. You can schedule it. You can respond to events. You can respond to social media. Those kick it off. There's 200 connectors that are available to you if you want to use those within the Logic Apps. Again, you can easily integrate with anything that's in Azure itself, and you can set up those monitors to make sure you're doing what you want to do and responding when you need to. So that's all I have for today. Is there any other questions that anybody else would want to discuss today? And if you want to open up the mic at this point, we could. All right. Well, if there's no other questions, I'd like to just thank you again for taking the time to listen to this talk on orchestrating your processes with Azure Logic Apps. And my name is Brian Gorman. Thank you. Oh, thank you. I appreciate it. Thank you for being here. All right. I think that's everybody. So I'm going to go ahead and stop the recording. Thank you very much for the opportunity to be a part of this.